Okay, year 9, welcome to part 3. Right, here's 2 more examples, okay? We've got to be really, really careful here. So we're going to do exactly the same thing. Let me just write down Sokatoa here because that's going to help me. Sokatoa. Again, let's label the sides. I'm just going to call this X and we're going to call this X. So if we label the sides here, this one is the opposite, this one is the adjacent, and this one is the hypotenuse, which we don't really care about. So this one is a TOA question because we're concerned with the opposite and the adjacent only. There's absolutely nothing about the hypotenuse in this question. So write down the formula, always write down the formula. Tan theta is equal to the opposite over the adjacent. Put in what I know, tan of the angle, 65, is equal to my opposite, which is 15, divided by x. Now notice this time it's slightly different than the other examples because this time the unknown, the x, is in the denominator of the fraction, not in the numerator. It's very, very straightforward. I can simply multiply both sides of my equation by x. So I get x times tan 65 equals 15. Now I can divide both sides of my equation by tan 65. And the reason why I can do that is because tan 65 is just a number. Basically, tan 65, what that means is what ratio is the correct ratio for the opposite to the adjacent of for an angle of 65 degrees. That's all it is. It's a number your calculator knows. Okay. Now, however, if you're not sure about that, then use those triangles. Okay. Tan theta equals your opposite over your adjacent. What we want to know is the adjacent. So the adjacent equals the opposite over tan theta. Okay, so you can use those triangles instead if you prefer. Okay, the actual answer, I'm going to use my calculator. 15 divided by tan 65. And according to my calculator, that is 7.00 centimetres to 3 significant figures. Okay, let's get rid of this. Let's do the second one. So again, let's label first. This is the adjacent, and this x here is the hypotenuse. So I've got adjacent and hypotenuse. The opposite I've got no interest in. So it's a opposite and hypotenuse, it's a sine. So sine of your angle equals your opposite over your hypotenuse. Sine 28 degrees, which is just a number. That's your calculator telling me what's the correct ratio for the sides. Is equal to, adjacent is 8 over the hypotenuse, which is x. So again, the x is in the denominator. So multiply both sides by x. And then divide both sides by sine 28. Sine 28 is just a number. X equals 8 divided by sine of 28 degrees. I want to be very clear. Sine is not a number. Sine is not a number. But sine 28 is a number. Okay? It's saying what is the correct ratio to use for opposite to hypotenuse for a 28 degree angle. Okay? And so again, I'll plot that into my calculator. 8 divided by sine 28. And that is equal to 17.0 centimetres to 3 significant figures. Okay? If I wasn't sure about the rearrangement, again, I could have used the triangle. Sine theta is the opposite over the hypotenuse. So therefore the hypotenuse is equal to O over sine theta, the opposite divided by sine theta. And so, that's effectively what I've got there. Okay? So I hope that makes sense. You really, really got to be careful about how you're going to rearrange your equations. All right, so let's just have a little check and see whether you understand. What is the correct calculation for this particular one? Stop your video and have a go. Well, hopefully you know this is the opposite, this is the adjacent. So it's a tan. It's tan of 71 is equal to your opposite, x over your adjacent 8. So x is equal, that's what easy one to rearrange, just times both sides by 8. 8 times tan 71 degrees. It's B. The answer is B. What about this one? Stop your video and have a go. Okay, we've got hypotenuse here, and this one x will be the opposite. So it's a sine because it's opposite and hypotenuse. So sine of your angle is equal to your opposite over your hypotenuse. X is equal to, times both sides by 10. 10 sine of 31 degrees. So it's this one here. Okay. Right. Okay, have a go at these 6 questions. And then when you've done them, I'm just going to reveal the answers, not the working out. And if you get any wrong, you can ask me and I'll help you. Okay, stop your video and have a go. Okay, to 3 significant figures, each of the answers is, this one 8.39, 15.6, 2.18 for C, D is 127 to 3 significant figures, not exact, but to 3 significant figures, 35.6 for the 5th one, and 564 to 3 significant figures for the last one. Again, none of those answers are exact, they're all rounded to 3 significant figures. Okay, so if you got any of those wrong, or all of them wrong, and you have no idea what you're doing, please just ask me and I'll do my best to help you. Okay, right, so let's just have a look at this one. Tanya writes the following. How can we tell she is wrong without doing any calculations? Okay, so basically Tanya's trying to find out this length here, okay, this one here, which is the adjacent. Okay, so she comes up with an answer of 14.3. Now, without doing any work, I know that's wrong. Well, how do I know? Because 14.3 is bigger than 12. And isn't the hypotenuse, this one is the hypotenuse, always has to be the biggest, the longest side. So you can check your work because common sense has to prevail. You should be able to understand which is the biggest side. And you should even be able to understand somewhat what the relationship between the other 2 sides are. For example, if you've got a really small angle, then this length here is going to be much larger than this length here. So the adjacent is going to be much bigger than the opposite. Alternatively, if you have a really large angle, then the adjacent will be small compared to the opposite. So common sense can prevail in checking your answer. You won't know you got it perfectly right, but if you've done something glaringly stupid and obviously wrong, then you will know. Okay, so what should have happened here? This is x. You've done the wrong rearrangement. We should have said cosine of 50 degrees is equal to, oh, that's what she's done wrong. X over 12. She didn't do the wrong rearrangement. She used the wrong function. She used tan when she should have used cos. Okay? So x should have been 12 times cos 50 degrees. I'm going to put that into my calculator. 12 times cosine of 50 is equal to 7.71. And now it's making a lot more sense. Okay, it's smaller than 12. Okay. Right, quick exam question. Stop your video and have a go. Okay, identify first that this is the opposite, this is the adjacent, and therefore it's a tan. Tan of your angle is equal to opposite over adjacent. Tan of 26 is equal to x over 8 x is equal to tan 26 degrees times 8, times by 8 on both sides of the equation. 8 times tan of 26 equals 3.90 centimetres to 2 decimal places. The question said 2 decimal places. Okay. Right, stop your video and have a go. Okay, the diagonal of this rectangle is 15 centimetres. Work out the value of y. Well, because it's a rectangle, we know it's a right-angled triangle. And since it's a right-angled triangle, we can either use Pythagoras or we can use trigonometry. We can't use Pythagoras because I only know one side, but I also know one side and an angle, so therefore it's trigonometry. Okay, so y is going to be opposite my angle, and this is going to be the hypotenuse, so it's a sine. Sine of my angle equals opposite over hypotenuse. Sine of 26 equals y over 15. Y is equal to 15 times sine 26. Okay, 15 times sine 26 is equal to 6.58 centimetres to 2 decimal places. Okay, read the question. Last one. Now, what do you notice here? This is not a right-angled triangle. This is an isosceles triangle. So you might think that you can't use trigonometry, but you can. Let's put this, what it wants to know is the height of this triangle. Well, let's put the height here instead. It would be the same length. Okay, and because it is, so, you know, this is also x. Because it is an isosceles triangle, we know that this is a right angle, and we know that this angle is half of this angle. So the angle is 17 degrees. Okay? Now, what side is x of, let me just highlight the right angle triangle we're talking about. Here is the right angle triangle. Okay? So we know that the x is the adjacent side, okay? And we also know actually this length, which is the opposite side, and we know that it's 3 centimetres. We know it's half because we're cutting an isosceles triangle in half. So with this right angle triangle, it's adjacent opposite, it's a tan. Tan of your angle is equal to the opposite divided by the adjacent. So tan of 17 degrees is equal to your opposite, which is 3, over your adjacent. Okay? Now, hopefully, common sense is telling you that the answer's got to be more than 3. Okay? So let's rearrange it correctly. Times both sides by x. And then divide both sides by tan 17. And now let's use a calculator. 3 divided by tan 17 should be more than 3. Yeah. 9.81 centimetres to 2 decimal places. Okay. So although some questions you'd not actually have a right angled triangle, well, you can make a right angled triangle. You can look for one, or you can create one yourself, and you just have to fill in the right information. Okay, so just because it's not a right angled triangle doesn't mean that it's not a trigonometry question. You've got to look for those right angled triangles. Okay, right, any problems, need any help?